Hi again, everybody. Pre-calculus students especially, I suppose, who would be watching this. Today we're going to talk some more about limits. This would be comparable to the 2-2 packet that we're going to be working through, but we're entitling this Limits 2A. Today, limits involving infinity. And two major groupings here. We're going to first of all look at limits when x approaches infinity, and then we're also going to look at when x approaches certain values and maybe the answer will be infinity. But first of all, let's look at this example here as x approaches infinity. You might recall on the last video we only looked at limits when x approached a certain number, and we saw how or the effects when x approached that value from the left and from the right, and then what that overall limit was. Now, this is actually quite similar to something we have studied already in this class back in first quarter, and this is similar to something called end behavior. And the notation for end behavior is written down here. Remember we said as x approached infinity, f of x approaches, and then we're not sure what that is. Maybe it might be a particular number, maybe it could be infinity, that type of thing. So I'm going to put this could be a particular number, and we'll see examples of that. Or it could be plus or minus infinity if the graph shoots way up or shoots way down. Now, on the bottom here we see that if a limit does exist when we have x approaching infinity like this, then it will be the same as a horizontal asymptote. And we'll see an example here that will illustrate that pretty well, I think. Okay, so that's some basic stuff to help get us started. We're going to go right to some examples. Alright, so here's our first example. The limit, and this looks kind of like a bear here, 6x squared minus x over 3x squared plus 1. And we want to look at the limit of this as x approaches infinity. So we're going to look at this a couple different ways. One, just by graphing and looking at the tables to help us figure out what this limit is. So here's the graph of this particular function. And clearly you can see that as x goes to infinity, it looks like this graph is indeed leveling out. We are going to have a horizontal asymptote here. And what will this horizontal asymptote be? Well, here's a good strategy to use your calculator to help you out. I could go to my table setup, and I just started at quite a big number at 10,000, and I had it go up by 1,000 at a time. So then I looked at the table, and certainly here's my results. So it's pretty apparent what my answer here will be, I think, looking at the table. Keep in mind, notice my highlighted number here, the actual y value is not exactly 2, although it is very, very close to 2. So I think we could pretty safely say that the limit of this function as x approaches infinity is 2. We could do the same thing as x approaches negative infinity as well. Take a look at our table and graphs and come up with a good conclusion as well. So remember, when x approaches infinity on these kind of limits, if there is an actual number, we'll see that leveling out of the graph, and we could think of this y equals 2 as a horizontal asymptote as well. There is an algebraic approach to this too, and I think we mentioned this when we were talking about end behavior last quarter. But it would be this, is to divide each term by the highest powered variable that we have here. Now, what do we mean by a term? Well, a term is something like 6x squared, that's a term, and x is a term. So basically anything that is separated by the positive or negative sign here. So I'm going to see if I can do this. You, on your notes, you'll be able to take a little bit more room. My highest powered variable here is x squared. So I'm going to divide everything by x squared here. Perfectly legal as long as x squared is not equal to 0. So just algebraically, we'll show you what we have left. We have 6x squared over x squared. I think you see that the x squareds will actually cancel out here, right? And so what I'll end up with then out of that first term is just plain 6. Meanwhile, the same thing here, one of the x's will cancel out, so I'll have 1 over x. That's my numerator. Meanwhile, in the denominator, I think you can see both these x squareds will cancel out, so I'll have 3. And here's the 1 over x squared again. Now, again, you might say this looks a lot worse than what we started at, but keep in mind we are thinking about this as x approaches infinity. And so we're thinking to ourselves, well, when x gets to be a really, really big number, well, then won't 1 over x, think of 1 over some tremendously huge number, won't that number be very close to 0? So I'm going to quasi-substitute a 0 in place of that expression, just because when we get to really large numbers, that's going to be so close to 0. Same thing in the numerator. If you imagine x squared, x getting very, very big, well, certainly x squared is going to be much bigger than that. Again, this whole expression is going to be equal to 0. So then when I look for my final answer here, notice all I have left is 6 divided by 3. And sure enough, that's that same 2 value that we had gotten when we explored this graphically. So this is just an algebraic approach. Again, it's good to look at limits, as in many calculus topics, from more than one point of view, more than one method of solving it. Now let's talk about infinite limits as x approaches some value. Again, we looked at before, previously, as x approached infinity, or negative infinity. Now let's actually look at x approaching a value. We did this in the first lesson, but now there might be some infinity involved. And typically when you do this, what's going to happen an awful lot is that you will see at x equals a, there will be a vertical asymptote. And again, this is going to be some place where the function is undefined more than likely. And we want to see what actually happens here when that x value approaches that place where the vertical asymptote will be. So here's a couple of examples. First one here that I've graphed on my calculator is 1 over x squared. I want to know what that limit is as x approaches 0. Now recall from our first lesson that when we do have a definite approaching value like this, we really do have to think about when x approaches from the left and also when x approaches from the right. So let's think about that in terms of this one. As x approaches, let me get my pen here. So as x approaches 0 from the left, I think we see that my limit is going to be positive infinity, right? And just to trace what's going on here, I'm getting closer to 0. I have to follow my function. It's just going to keep going higher and higher and higher. So from the left, it's going to be infinity. And as x approaches 0 from the right, again, the same type of thing, following the function. And remember, limits are y values, and so clearly, again, it's going to be infinity. Now, because these two agree, I can say that my overall limit here is going to be infinity. So far, so good. Let's look at the next example over here. And this time, I have 1 over x, so this is a slightly different function. You can see looks different when you graph this. So now, again, I have to look at my left-hand limit and my right-hand limits. So in this case, let's look at x approaching 0 from the left. Again, I have to follow my function. So from the left, this time I'm going to go down and down and down, so my y values are going to get very small. We could essentially say that's going to be negative infinity. And you might guess what's going to happen here now as x approaches 0 from the right. And again, following my function like this, now my y values are going to get extremely, extremely large. In fact, they're going to be positive infinity. So what am I going to say now for my overall limit? Well, like we learned in that first lesson, in order for there to be an overall limit, these left and right hand limits have to agree. So here's a case in my famous Lindsay Lohan voice, I'm going to say does not exist. These two don't agree. So that's the first part of this lesson, Limits 2A. We're going to be working on some problems like this in class and practicing this some more. So thanks for listening, and we'll see you guys in class tomorrow. Bye now.